rainy day in Chennai. I know you have a lot going on in the business as well as at home, so thank you so much for taking the time to join. Uh,
Sure.
today is today is Saturday, July 12th, 8 p.m. This is actually the program originally scheduled for June, but because of various logistical reasons, we had to move it to July. So this is actually the June program that we are doing now. Uh, so I'll just quickly run through this presentation about the program and about the speaker, and then Shweta and Satya will take the program forward. So people who are joining who may not know about CG Connect, CG Connect is a private online platform that we put together to help CG alumni, students, and faculty to network and connect with each other to mutually benefit from the interactions. cgconnect.com is the website. About this particular program, CG Sea Level Connect series, it's a 1 hour online video podcast that we do once a month with one successful CG alumni guest speaker. This is the 47th program. We have done 47 episodes so far, and we had speakers, diverse pool of CEG alumni. We had men and women, people from India as well as from overseas, C-level people, lead academic people, startup founders, bureaucrats. So we try to find a mix of various backgrounds. The common theme is all of them are CEG alumni in positions of power and influence, and different industries, different backgrounds, and different personalities. And all the programs are available in our YouTube channel. This program is scheduled for the last weekend of every month. As I said, this program was originally scheduled for last weekend of June. The program is open and free to all CEG alumni, CEG students. Occasionally, I also allow other college students to join on specific requests. The sessions are recorded, and the recording will be available in our CEG YouTube channel. And of course, you have a website for any further information about our CG Connect series. In addition to this program, under the CG Connect umbrella, other initiatives are run. One is a CG Field Insights program, which is a program similar to the one that we are running now. It's a quarterly program where we bring in a CG alumni industry expert to talk about the industry, about the research, employment, and startup opportunities in the particular industry. And so far, we covered air transportation, EV, crypto, weather, forecasting, sustainability. In fact, EV was actually run by Manu Iyer for us, Srinath. Yeah. CG Connect Startup and Entrepreneur Networking Meet is another event that we run. We've done a couple of events in Chennai. Next week, next Saturday, we are running the CG Connect Startup event in San Francisco. Next Saturday, actually. Is expecting quite a lot of CEG people from the Bay Area to attend. The last point is CG Connect free webinars. I also have put together several webinars based on things that I encountered, experienced, etc., in order to contribute to people who can learn from that. So various different topics that I work on, and many of them have been done many different times, both for alumni as well as outside audience. So if there's any interest in any of them, certainly I'll be happy to do the webinar for people in the audience. So today's program is number 47. A few guidelines for those of you who joined for the first time. Please stay muted, except for the hosts and the guest. I would like everyone to turn off your video. At the second half, during the second half of the program, I'll ask everyone to turn on the video to take a screenshot. The entire session, as I said earlier, is recorded. The recording will be available on our CG Connect YouTube channel. During the program, if you have any questions for either the guest or the host, you can use the Slido program, which I will describe in a few minutes in the next few slides. There will be periodic live polls in Slido. In addition to the opportunity to ask questions to the speaker and the host, there will also be a place where you can respond to polls. The polls will be actually initiated by us, the hosts. I would appreciate if all of you can participate in the poll. And during the second half of the program, if your name is called, please unmute to ask your question. So today's guest speaker is Srinath Ravichandran, rocket man of CEG, 2006 CEG EEE, co-founder and CEO of AgniKul Cosmos. I'll be the host. Satya and Shweta are going to run the program today, and Partha is our tech support. For joining Slido, you can go to any device, either it's mobile, laptop, desktop, etc., and then go to any browser and type slido.com. Once you go to slido.com, you'll see a place where you have to enter your Slido code. And today's Slido code is 2500-367, 2500-367. Once you enter the code, you will get to a screen like this. where you'll have the opportunity to respond to polls as well as ask questions. There will be polls tab and a Q&A tab. You can go to the Q&A tab and type your questions anytime, and you can go to the polls tab to respond to any of the polls you're pushing. That's all I had. So with that, again, thank you and welcome, Srinath. And I'm going to hand it over to Satya and Sweta to take it forward now. Good luck, guys, and let's go.
Thank you, Vish. So glad to welcome the rocket man Srinath Ravichandran and the founder of AgniKul Cosmos. And they have built India's first 3D printed rocket engine. And he is a 2006 graduate from Electrical and Electronics Engineering. Thank you for joining us today, Srinath. So to begin with, at a time when the government agencies like the ISRO or the NASA, the ESA, the JAXA has been dominating the sector, what motivated you to invest in the space domain, space sector?
I grew up as a space enthusiast, always been one all my life. So actually the question is, why did it take so long to get to space as opposed to why did I do space? I wanted to do, I grew up in Chennai, wanted to do aeronautical engineering, but everyone around me, family, friends, everyone told me to do a safe course so that I'll get a job. So I did electrical engineering because I also liked that and it was considered one of the safer courses at the time. And after that, I got a job at an electrical engineering company. Then moved on to finance, and that was because everyone around me was making more money and seemed to be doing more interesting work. So after all that, I applied for a master's in financial engineering. So moved to New York to do it in Columbia University in New York. And then next 7 years was in Wall Street. But in the middle of all that, I realized I just had to go back to my original passion, which is space tech. So quit that job, did a second master's degree in aerospace engineering, and then moved to Los Angeles because that's where SpaceX is. And around SpaceX, a lot of activity was happening. And that's when I realized there is a problem to solve and also some money to be made, if possible, as a business. And so then came the switch to core aerospace for a career, and then also moved to India because it just felt like the right place to do a lot of this stuff. And anyway, it's good to, whenever you're narrow, you're always better off doing it in your home ground because it's always dual use technology and so on. So people always consider it as one step away from defense. So cold called a bunch of people, and then one professor out of ID Madras was supportive enough to help someone with this kind of a convoluted career path. And so with that, AgniKul started. So yeah, I think the answer to your question is the question can be rephrased. But yeah.
But while CG is a dream for many, CG has been a backup option for you. I can see that. But come back to India and prevented the brain drain and building for the world from in India and increasing India's economy and contribution of India in the space sector. Thank you so much for that. Right. Yeah. So, yeah. Over to Satyapriya.
Yeah. So, what are your aspirations, Srinath? What are India's aspirations in the space tech?
So I think my aspirations are every time whenever I used to follow space tech, when I used to read hard science fiction, anything, I always used to feel like getting to space was the hardest part, right? And then after that, if you are in orbit, if you are in deep space, actually it's a very benign environment. Nothing can harm you. It's mostly you can be in peace, right? So I felt getting to space is the hardest part. And then when I was growing up, from Chennai, actually, I don't know if you know this, you can just go to a somewhat of a tall building, a terrace, and look northward during a launch, and you will see the PSLV launches. It's visible to the naked eye on a regular day. So I grew up seeing all that. So the rocketing was always there in me. So I felt we should build a solution which makes space transportation as normal as possible, right? So that's where it started. Yeah. And because that means suddenly it's like a pathway has opened up. Once a pathway has opened up, a lot of people will go there, and then a lot of more things can be done. So that is what our vision is: enabling space transportation in as many ways as possible, as affordably as possible. Yeah, I think India's aspirations are, much beyond just opening up space transportation itself, right? I think India, actually, given the, where we were as a country when our space program started, I think it's actually remarkable. We had some amazing founding, visionaries in our space program. People who decided that this country should have a space program despite being a developing country, despite having to build even basic building blocks. Like, we had to regularize road work, we had to regularize transportation, we had to regularize agriculture. But at the same time, someone was actually spending some money on space tech, which is like a phenomenal decision. And we're seeing the fruits of that. If we all can come and watch with bated breath about probe landing on the moon for Chandrayaan 3, I think that would not have been possible unless the whole game began like 50 years ago, right? So it's remarkable that that's what the country is capable of doing. And we, from my whatever my global connections, I know India space program stands among the top 3, 4 in the world.
Yeah, we
Right.
recently saw your article in Outlook Business,
Okay.
which your startup was listed among Zerodha, Freshworks, and all the things. This is being circulated among the startups group. So a big congrats on that.
Thank you. Thank you.
So
So
how
yeah,
far are we like traveling to space? Just like Wish is traveling to San Francisco. How long will it take for us to travel to Mars?
I think about a decade or so. Okay, maybe if it has to be that normal, probably 2 decades. But I think actual commute would start somewhere in a decade or so. We need to
Okay.
develop some technologies inside the country for that. I don't know if all technologies are available, right? Making a human survive in space involves actually building, like, oxygen generation in space, and waste management in space, a bunch of different technologies that are not usually considered space tech. Right. So that, I think ISRO is working on it as a part of the Gaganyaan program. So we should be there. Yeah, I think 20 years. It'll be much more normal, I think, across the world, not only for India, across the world. I think space travel will become a little normal.
And Srinath, with respect to the startup ecosystem that's been evolving, how is it different from the government space? What is the difference in the approach with respect to the government?
You mean in terms of building like a space tech
Yes,
product,
the
or?
private agencies, I think they're more faster, but how is it different from the ISRO? They've also been launching vehicles and all, right?
So I think as a government, you have a lot more constraints in some way, right? And you're also usually bound by, different goals, right? As a startup, particularly if you're a very regular venture capital funded startup, there is at least one clear goal towards making money for your shareholders, right? In a government space program, that is usually a second priority. In a government space program, there is a bigger focus on national interest, bigger focus on developing technology for the country. There is bigger focus on adhering to the population in terms of whatever different sectors of the society need, and so on. As a startup, even though the vision usually falls among one of these things, there is a lot more focus and attention on also being profitable, also maximizing returns for shareholders. The typical startup, right? I mean, startup is a startup. So I think that makes a big difference in terms of how we operate. We will have to be nimble, we will have to be flexible, we'll have to work with whatever we get access to. We can't say that we need $100 million to make the first one penny for our investors. So a lot of those nuances are there that a government may not be constrained by, but at the same time government also has to follow process, procedure. There are a lot more, there is bureaucracy involved, so they may be slow. So that's the usual government versus private story.
Okay, can we say, do you have a lot more freedom?
Yeah, I think in some sense we have a lot more freedom. In some sense we don't. Like as I told you, there is no freedom in not making money, right?
Okay.
So that there's no freedom there, but there is freedom in quicker decision making. Being able to to go behind a vision, just choose a vision and go behind it. All those things are, yeah, that's there for any startup.
Okay. So talking about the main thing about rocket launches, can you take us through the journey of a rocket launch? And there could be some Houston, there's a problem, and what are those challenges that you encountered?
Sure. So just 2, 3 points about rockets to keep in mind as we tell the story, right? One is rockets are always designed to be operating at the very limit of what they can take. So what they call as safety margins, right? Just there. Like a little bit off, you will fail. It's always like that because that's what it takes to put something meaningful in orbit, right? A rocket is not, it's a machine that goes really fast. That's all. I want to demystify that part at least. There's nothing, if you're building a machine that goes at 7.2 kilometers per second, in 1 second, if you're able to go 7.2 kilometers and your velocity direction is, parallel to the Earth's, like a tangent to the Earth's surface, then you're basically in orbit. So you're building a machine that will go really fast. All of this hype is about that only. Building a fast going machine. Now that fast going machine to go that fast, given Earth's gravitational well, given our atmosphere, you have very less margin. Everything has to be just right. You're pushing every system to its very limit. Otherwise, it becomes too heavy and you can't get to orbit. So the last part of it is there's so many different systems. There is electronics, there's software, there is engines, there are tanks, there are aerodynamic surfaces, there are motors. So everything has to work together. So these are the features of a rocket. It's a fast moving machine. It has a bunch of technology in it, and everything is operating at the very brink at which it can. If you push it a little more, it will fail. And you need to operate like that because that's how you will get enough mass to go to orbit. So what does a typical launch look like? Typical launch looks like you're checking everything over and over and over and over and over. It is the whole point of a launch. When you see a countdown, when you see anything, is you're just checking if all systems are okay. It's not like that's the first time you're checking. That must be the 100th time you're checking. In fact, throughout your journey, after you built your rocket, you're only checking. Nothing else you're doing. Because as I told you, the wave margins are very thin. So the countdown, and I think, by the way, I'm a firm believer in countdowns are being very anxiety creating, event. It's an anxiety creating event, right? When someone simply counts down and with you watching at a screen when you have nothing to do, it is meant to create anxiety, I think. But that's the only way in which you can synchronize so many teams. When a launch happens, you're synchronizing at least 20, 30 teams across the country. The telemetry teams, your rocket team, your launch pad team, the ground safety, flight safety. There is so many different. It's like an event, right? It's like a wedding actually. So many different people come together. They do one thing for a very limited, very focused period of time. And just like in your weddings, you have an auspicious time. Here also you have a launch window. And once that is over, you all go back. That's all. That's how it works. So to synchronize, how do you keep everyone to the dot, right? So that is where the countdown comes in. And you also use it to time your mission correctly so that you can go to the right location and so on. Because with Earth also rotating and you also moving relative to Earth, to get to a particular orbit at a particular time, you need to have a particular window. So that is what happens in a countdown. And because everything is operating at wafer thin margins, unless you're very, very rigorous about reliability and quality, usually there are some minor setbacks. I'm not talking about failures. I'm not talking about like blowing up of rockets. I'm talking about things like, oh, okay, somewhere there was a leak. Okay, stop your countdown, go back, start again after you fix the leak. Oh, wait, this computer didn't have this particular, there was this software was not perfectly uploaded. So, stop your countdown, refresh your computer, load it back. Something like minor issues, but they keep coming because everything is pushed to that limit. So that's how a countdown feels like. We went through that for our launch last year. It was a 6-hour countdown. Yeah, and even though if I look at it now, like 6 hours always looks like a lot of time. I don't know where it goes. Suddenly it's like T minus 6 hours, everyone claps. There is this moment where you are like, okay, we're starting the countdown. ISRO announces it. And then suddenly before you know it, you're like T minus 5 minutes, automated launch sequence starts, and suddenly the vehicle is lifting off. So that's how it felt for me. But yeah, that's basically what you're trying to do with the launch.
Okay. So that sounds, and the successful launch would be the feast of the wedding, right?
That's right.
Right. Okay. And so how would the
Of course,
testing process
definitely.
go?
Testing process? Sorry?
No, is it just checking? Like, what do you mean? How do you test the systems?
Oh, so multiple tests, right? So it's like you're basically putting a thermometer on bunch of people and checking if their body temperature is okay. It's like that. You constantly check for health of every system. For all the pressures, you're constantly checking for pressures, constantly checking for temperatures, for your computer packages, checking for voltage level, current levels, how much heat they are, how hot they are. You're checking for battery temperatures, a bunch of these things in the loop. So over and over and over, these key checks keep happening, and also usually in a countdown, you're doing some operation like you're filling propellant or you're making sure your gases are getting pressurized. So a bunch of these things are also happening. So those the dynamic changes are also being monitored, and your other system health is also being checked. So
Okay.
this is what the checking process. The testing process actually is one step before this, where you've not yet said that you're ready to launch, but you're actually making sure that all the systems together fly on the ground, working on the ground as if they'll be flying. So it's all there's a point called a stage test, where if you basically clamp down the rocket and fire all your engines for some time, right? It's almost like if I remove the clamp, it will fly. So that is the testing program, and that is again built piece by piece. Engines are tested separately, tanks are tested separately, software is tested separately, electronics is tested separately. Then things are put together and tested. But you can only test so much because final test is flight only.
Mm. Okay.
So that's what happens.
That sounds quite intense.
Yeah.
But I would like to ask how much do you usually invest in building a rocket?
So it depends on the size. It depends on, a lot of things. But I can tell you where the money goes. In fact, actually, it's one of the exercises I did before starting AgniKul, right? Because when I wanted to start a rocket company, of course, I'd worked in Wall Street, and also I know some Excel. I can do some projections with Excel. So I ended up digging where money goes to build a rocket company. And you won't believe it, the only place that you can't get, that only thing that you can't get easily is testing facilities. We interestingly just spoke about that, but because see what flies when you look at a rocket launch, say you're looking at a PSLV or you're looking at our rocket and Agniban, what flies is actually a fraction of what was actually needed to get there. Literally like a fraction. Like I'm talking about like 2%, 3% of the total money, right? And then there are machines that are needed to manufacture, right? You have to make a tank, you have to make an engine, you have to make your PCBs, you have to make your flight computers, your nose cone, so many structures. The manufacturing facilities are costly, but they are actually already there. Like there is a lot of industry already today, right? That's not a problem. So that part is not a hard thing to conquer. So the only thing that's not there easily to accessible is testing facilities. Okay, I get an engine. I know who will make engines, or I know various people with whom I can make engines. But then once I get the engine made, where do I test it? And there is no facility for that unless you go to an ISRO facility or build yourself. So that's where the money goes. Testing facilities, testing. And the other hard thing is, if your testing facility is going to tell you that this engine can fly, then it has to be better than the quality of the engine, right? Otherwise, it's like a scale. If you use a scale to measure a distance, then it has to be accurate enough, more accurate than what you're measuring, right? Only then it makes sense. So your testing facility will have to be more precise than the system it is measuring. And rockets already need precise systems. So you need to build all these high precision uh, testing facilities, which will be a usually a big cash infrastructure. So, but that's where at least I spent all my money. Whatever you raised about like from $50 million so far. Bulk of it is going into building testing facilities. That's all. Actually, the rocket part is a small fraction of that.
Okay.
So that's where the money.
So talking of safety, what are all the regulations that space tech companies need to consider? Because recently there was a blast in SpaceX when they tested the rocket in Texas. So how can one manage such kind of hazards? What are the regulations?
Yeah, so you're dealing with a lot of high energy items, right? Like kerosene or methane and oxygen, and these are all at high concentration level. So you're always at this safety hazard. So there are very clear guidelines for ground testing. Whenever you do a ground test, how far the fuel should be from your, oxidizer, what temperatures it should be at, and so on. And in every rig or every test facility or every storage facility usually has an abort, where if you hit the abort, even if every system in the facility fails, you can at least safely come out of the test. But there are still situations where, like for example, in that SpaceX example, you said they had actually filled up, they were doing a stage test, they had filled up their propellants. And so obviously both the propellants are very close together, the fuel and the oxidizer are close together. And at that time, if there is some leak or something, it will just explode. So the way in those situations where how safety is enforced is by saying the whole operations are remote. right? So even in our countdown, there is a non-remote phase and a remote phase. And once you're in remote phase, people are not allowed anywhere for a safety distance. So that is how we enforce safety. And there is always a manual about it. We don't trust hardware beyond or software beyond a certain point. So literally hardwired, you pull the plug, right? And you should be able to do that from the control room. So there is one button which the mission director or the testing director or the topmost person in the testing hierarchy has access to, and also the safety director has access to. And they can hit, and he or she can hit that button, and at that instant, entirety of the way the facility is automatically brought to a safe state. But usually that's also expensive. Nothing will blow up, but then you waste a lot of you would have wasted a lot of effort to get to that point, right? So all of that is gone. And the other interesting human angle here is not to keep the safety director and the test director in the same room. This is something we learned across. I mean, it's a phenomenon across all agencies. Even in ISRO, they do it. The person responsible for safety is always incentivized to stop the test. The person responsible for the test is always incentivized to do the test. You can't have them in the same room. You have to have different hierarchies for each one of them, and they both actually culminate at their own testing director levels, the safety director and testing director. Independently, we agree on what should be done. The test before the test. During the test, they don't talk. If there is a certain set of if conditions that are hit, the safety director has all the right to, independently go and hit the abort button. And that's easier said in this meeting or in this call than actually you need to. There are hundreds of questions that come after that. But at least in that moment, you should not be influencing people, right? So that's why they do it. So that's another way in which we inculcate that safety thing. And we always keep talking about safety. It's one of the most commonly repeated topics. You should talk about it enough to have people for people to have safety in their mind, but also not talk too much about it so that it becomes like that
Yeah,
alarm that
kind
rings
of
in the morning that you
pessimistic.
never wake up to. Yeah.
Yeah.
So yeah.
Okay, so Srinath, what is the mission at AgniKul Cosmos? I've read it's about democratizing space. Can you brief us a little about it?
Yeah. So as I said, space is its own new environment, its own new, it's a new place to be, right? But then getting there is incredibly hard. Right from the technology it takes to the cost it takes to the timeline it takes to who all can get there, what all can get there. Every single parameter is it's not friendly for doing that, right? So entirety of space is being that far away distant place because of the access. The way I always think about it is all the commercial activity today in space happens in what we call as low Earth orbit, right? Low Earth orbit is a class of orbits which are somewhere between say 300 to some 700 kilometers. That's like Chennai to Bangalore in the upward direction. That's all. You're not going too far. Deep space, Mars, Moon, and all are very far away. But the commercial activity today happens 300 kilometers above, 500 kilometers above. The space station is in that class. But to get there, you can look at the amount of pain that people go through, right? Amount of confusion that is there, amount of cost that is involved. It's literally Chennai to Bangalore in the upward direction is low Earth orbit. So this thought was always there in my mind. Everything that I've always read in my childhood and everything was always about like, if you can go there, then all these things will be easier. The only thing is you can't go there. So I've always been fascinated by rockets because rockets are the systems that take you from Earth, from a surface and from some point on the surface of Earth to an orbit, right? And so we decided that AgniKul's mission should be about making sure that getting to space should be easy, fast, quick, cheap, all of those, good adjectives, right? So that is what we're building. So all of our technology, all our systems are conceived around what can make this technology actually accessible to everyone.
Okay.
How can rockets be a commonplace thing? And that's the journey.
That's interesting. And also, what makes your startup very different from the others is you make 3D printed engines, right? How is it different from the traditional engines?
Yeah. So see, when we had to, and just I'll give a bit of context on that, right? So for 60 years or 70 years, we have been flying rockets as a species, right? Uh, And so nothing, what is new in rockets, right? Rockets have always been around. 1969, we put a human on another body, right? That's like amazing, actually. So the only thing that was not, really well defined for today is the fact that there is your satellites have changed. What goes on a rocket has changed. Before, though, they used to be big systems. Satellites used to be very far away, very heavy, very few in number. But today, they're with satellites being electronic systems, they've all changed. And so, you're having these small pieces of small objects. They're cheaper, they go very close, and they're very light. But rockets are still stuck in the past. They were meant for those big satellites. So there was that gap. Rockets are big, but satellites have changed. They've become small and more in number. So, but this gap was not being addressed, and instead people were trying to force fit small satellites into large rockets. So that was causing a lot of inefficiency. Then we realized, okay, if everything is small, then make the rocket also small. That's sort of the no-brainer approach to it, right? So okay, make a small rocket. But then what is the problem with a small rocket? The small rocket has an economics problem, not an engineering problem. The economics problem is when you take a big machine, and this actually applies universally everywhere in any industry actually. If you take a big machine and try to make it small and work for a smaller size, your overheads will go up. The unit economics means like for per unit output, the dollars you incur or rupees you incur will be higher, right? So your price goes up that way. So we figured when you take a big rocket and you try to do the economics costing of it to make a small rocket, suddenly the cost of the rocket is too high for what it is meant to do. It is still cheaper in an absolute sense, but relatively it's too costly. So then no one is making useful rockets. It'll become a hobby rocket. It'll be nice. It'll go once and maybe people will clap, but then beyond that, no one will get utility from it, right? So then we realized we are fighting this concept in this in what they teach in economics is economics of scale. You can't fight that. That is a well established. It's almost like a law. So the only way to beat economies of scale is to work around it. And the way to work around it is to figure out new technology itself that will work at smaller scale. So that's where 3D printing comes. 3D printing is was one such technology where you can make a small rocket engine and still keep the cost at a unit economics level comparable to a very large engine. And the technologies, the conventional manufacturing technologies used for very large engines, these have been optimized over decades, right? Since 1950s, people have been making big rocket engines. So there is very little to squeeze in terms of pricing.
Okay.
But no one has, at least rigorously made small engines. Everyone does one or two in some hobby level, test level. Oh, before I make a big engine, I'll make a small engine. But no one has productionized a small engine.
Okay.
So when we wanted to figure out what will make this pricing work, we had to figure out new technologies that will work. And that's where 3D printing came in. The advantage of 3D printing is you can build your rocket engine in a very unique way. We can build it layer by layer. I always think of it like it literally for me feels like making dosa in a 3-dimensional way, right? You put a layer of metal and then you weld it, then put one more layer, and literally the engine is built like a pot actually upward. So that concept, that technology allowed us to keep the cost up. And in fact, 3D printing is one thing that gets spoken about quite a bit about us in the media and so on. It's somewhat like a buzzword, right? But actually, there are a host of technologies where everything that we were doing, like another thing that I like to talk about is the way our computers are built, right? They're all built using they run on Linux operating system, right? And the whole rocket from an operating system, from a computer standpoint, is like my flight computer wants to go to space. Oh, but wait, I need a peripheral. Okay, I'll put an engine to it. Oh, but the engine needs a tank with fuel, so I'll put a tank. So the whole concept of that a computer wanting to go to space and how that set of software will work is how we have built that. So again, building computers that run on Linux, there real-time systems that work on Ethernet. That approach where again, what will work in this size for the right price. That's how that is in fact the core strategy of building our rocket.
Okay, we know this applied for rockets also because recently we purchased a sofa. It was a 5-seater and the 4-seater was one cost, and we bought the 1-seater separately, and he's charging half the price of the 4-seater.
Spot on. Economies of scale. Yes.
Okay. So speaking about the payloads in your rocket, so what type of satellites do you usually send?
So
And
very flexible. It's like a truck. Anything can come. Mostly the customer. I can talk from the customer side and say, a lot of people go to space for taking photos or for helping with communication. But we as a company are indifferent. We are that empty Amazon truck or empty, a Tata Ace, whatever you call it.
logistics.
Anyone can put it. It's a logistics. It's a machine that will take a hardware object and put it very fast in a particular direction. That can be a satellite. That can be a test article. That can be whatever else we want. Right. So that's how we think about it.
So what happens to the rocket after you
Can you give
launch it?
some insight? Shweta, just taking it on the 3D printing side. Can you give in 3D printing? Like it has wide applications, right? From IIT Madras has been building construction, been using that in construction industry. IISc is using that for building healthcare. They are building cornea for eye health. So how do students prepare a career in 3D printing? Like what kind of interdisciplinary research can they?
So 3D printing again is very wide in terms of the materials that are used, right? It's very different technology everywhere. The concept of 3D printing, as opposed to any other usual, manufacturing processes, 3D printing is an additive process, right? You create whatever you want wherever you want, right? As opposed to traditional manufacturing of anything, which is always about removal of stuff. You take a bunch of stuff and you put it into a mold, and the waste is removed, and what is there is the remaining. That's the usual process. Or you take metal and you shave out what you want, or you carve out what you want, and the remaining is what you want, right? So that is the usual process. Additive manufacturing flips that on the side and says, hey, I will have concrete. I'll have concrete attached to a robotic arm and mixed in a particular manner where I can actually go and build that with my moving my robotic arm, right? So I'm building a house with a repainting way. Or I could take metal. I can fuse metal the way I want by just putting a layer of powder, taking a welding torch, and moving the welding torch wherever I want, so that the object is created. Similar thing with biological tissues, right? So it's a completely different branch, and based on the kind of material, based on what you're trying to 3D print. But today, there are a lot of people, at least at a master's level, a lot of universities offer courses. There's a lot of material available online. But the best way is to actually figure out a lab or some industry, some company or something is doing that and try to be associated with it. That's how we also learned it. It's not like we had 3D printing experts when we started. We just try to associate ourselves with as many government institutes as possible, as many facilities as possible, that we're working on 3D printing. And we figured, okay, what are the nuances? What is actually the real problem? The tricks of the trade are there, right? What really is there in 3D printing? And with that, we got started. It's a very, very popular, technology now in aerospace. But I think people are now starting to realize it has wide applications in every industry. So it's a very interesting place to be prepared in. And also very fascinating because results are that quick. Like I always tell my team, right? 3D printing allows you to iterate on hardware at the speed of software. So literally, you can see things happen real time. That is, with traditional manufacturing, it's a very patience testing system. To make a mold, you have to make a fixture, and then you have to take the raw material, then you have to make some process on it, and everything has to work. And before you think of an idea and you see it, you spend lakhs of money and at least 2 months. Here, I have an idea. I go to a CAD model, make it 3D printable, design for 3D printing, go for printing. 5 days, I have the component in my hand. So it's really amazing in terms of seeing quick iterations happen.
Okay, so I think
Sure.
quite a lot of ground, Srinath, so far. Very
And
nice.
shifting
Just want to have a
gears,
quick
you're an
question. All of
aviation
us know about.
engineer.
Uh, Aerospace engineering, I think, is what you're talking about, right? I did that course too before
Yeah,
starting
Wish
AgniKul. I now
started
finished
something.
it.
Okay. I think Wish
Yeah, I
started some
think Vinath
question. Wish
started
had some
something.
question. Yeah.
No, I think I was asking you that the only rocket I know of is Diwali rocket. So, I, is the concept of what how you make Diwali rocket the same as how you make? I guess both trying to achieve the same thing, right? Trying to go up.
Yeah,
Uh,
the only thing is with these commercial rockets, the direction in which you're adding speed matters a lot. With a Diwali rocket, or what is more professionally called a sounding rocket, which is basically a very well made Diwali rocket, is that you simply impart velocity in whatever direction you can. So it'll go far, but it'll come back, right? But if you want to be in orbit, you have to go. You have to be tangent. Your velocity has to be tangential to Earth's surface. That's the only difference. But to do that correction, to take velocity in one direction and add it in another direction, that is a lot of effort. So that's what makes this complex.
Shri, can we
Interesting,
see
interesting.
a rocket named after you sooner?
Sorry, what?
Can we see a rocket named after you sooner?
After me? No. I
No.
think a lot of other names can be given to rockets.
Okay.
Yeah.
I guess so. This business that you're in right now, who are your customers? I'm just curious. Who would be the people
Yeah.
who will
The
be working
same
with
thing
you
I
to
also had.
give you money?
Yes.
Yeah.
Yeah, any small satellite maker is a customer. So people making communication satellites, imaging satellites, people making pods for experiments in space, all of these people are customers. So if you want name a few, Utelsat, Intelsat, Viasat, OneWeb, a lot of these people, right? These are all these guys make satellites, so they are our customers basically.
So you're not in the satellite business. You're mostly in the rocket business.
Yes, we are in the rocket business. We make the machine that takes a satellite to space.
So when you talk about space tech and grow and improvements and developments in space tech, are we talking more about satellite related work or rocket related work, or both?
Both. I think it's happening everywhere, right? There's a lot of innovation happening across all frontiers. I think rockets, a lot more has to happen immediately, because only then the rest of the market will grow. Otherwise, people will still be making stuff on the
Hmm.
surface. That is not going to be very helpful, right? So I think the need is probably highest in the rocket space. Of course, SpaceX has done a very good job in normalizing it to a large level, but still there are a lot of problems with their systems. So
Hmm.
I think there's still a lot more need there. But every other sector is also growing. You have people making better cameras, better imaging sensors, better transponders, uh, better ways to communicate in space itself. And
Hmm.
then, of course, you have the whole data analytics part. Whatever comes back from a satellite, what do you do with it? And of course, now you can add an AI layer to everything. So that also is happening.
Hmm. So when people when customers come to you and they want to use your rocket to launch, so you are taking responsibility for their whatever they have created as well.
That's right. That's right.
And
Yeah.
and so if you are launching and God forbid it doesn't work, what happens after that?
So
You
people
got to,
take insurance, right?
uh,
So money wise, you're okay. I mean, we are also covered. We take launch insurance for our rockets. They take launch services insurance for their satellite during the launch phase.
mm,
But no one will fly quickly with us again. You'll have to do a lot of convincing. You'll have to
mm,
tell people why the failure happened, why it won't happen again,
mm,
and you'll have to share data. And the more savvy the customer, the more they would want to understand why it did not happen again and so on.
mm. And you have customers in India and overseas, or mostly overseas
Mostly
today?
overseas. I know a couple of people in India who may be ready by the time we are doing our third or fourth launch. So we'll also fly. But in India, it's a very small community, right? Globally, I think people are ready to launch with us later this year itself. So yeah, trying to make that work.
And how many such companies like you exist today that are commercially viable, or feasible and viable?
Rocket companies, probably I think 10 of them across the world.
10.
Only, yeah, 10. I think only one company has actually been successfully flying, which is Rocket Lab. Other than that, Rocket Lab is based out of US. They also make small rockets.
Mm,
Other than that, everyone is still in that phase of they still are yet to do a launch, or they've done a partial launch or something like that. So that's where the industry is.
And from India, you're the only one right now.
Yeah, we are one. I think a few recently started. I heard about a couple of companies based in Bangalore and even one in Tamil Nadu and near Thoothukudi. I heard of a company doing it. Hyderabad has a company called Skyroad. They have been around for a while too. They make solid propellant rockets, so more like missiles, but they also fly rockets. So yeah, it's there in India. Actually, we have. Someone was actually telling me the other day that we are the only country today which has as many rocket companies as satellite companies. I don't know if that's a good thing, but it's there.
Interesting. Go ahead. Back to you guys, Satya and Shweta.
Yeah, one thing, like we had a lot of this Boeing aircrafts suffering last few months, right? They have been coming back. So, is there an opportunity for a Make in India brand like Boeing to, build a more efficient aircrafts through 3D printing?
I think efficiency wise, particularly from a fuel and mass efficiency, absolutely. Right, 3D printed parts are usually lighter for the same functional outcome that you expect from them. The failures we've recently seen are very. I've always seen them to be more electronic, software focused in nature. I think we are not getting good software testers to be a part of these teams. That's
Okay.
my understanding.
Okay.
Because mechanical systems wise, the testing programs are so visible and so observable, right? So you will very rarely find that to be a problem. I'm seeing a lot of issues, right, from big issues that have unfortunately cost even lives, all the way to small things. Everything is like a software glitch.
Mm,
I recently also, I think one of ISRO's missions, SSLV, there was a software glitch. Before
mm,
that, the Chandrayaan 2 mission also, there was a suspected software glitch, right? We don't know the exact reason, at least it's not fully known in the public domain. Multiple other problems, software. And so we have been and it's very difficult also now to find these out because the kind of software has also changed. Before they used to write code where it's like on one huge loop. Just write code, and then the whole thing will just run again. Now we are thinking about operating systems, apps, and different apps being scheduled at different times, and they're sharing data, variables being shared. That's all. It's like the indirect complexity of writing regular code for a laptop is now being put onto a flight computer. So there are a lot more chances for bugs and so on. So like I'm actually always very worried about the software bugs in our own vehicles also because you never like how much ever testing you do, you're always worried about that one extremely rare but perfect coincidence that can happen where some bug will actually show up,
mm,
right?
mm.
So yeah.
Super. So let's go to the questions,
Yeah.
Srinath, the audience questions. We got a bunch of questions lined up.
Okay.
So let's first start off with the first question. Anonymous. What are the biggest challenges in your early stage of the company? Talent? Question mark. Funding? Question mark. Regulations? Question mark.
Mm, all three, so I'll rank them maybe, right? I think funding was hard
Mm,
because we didn't know how to sell the idea of a business built around building rockets. At least I didn't know how to do that at that time. Now it's a lot better. So that time that was hard. Policy we put as second because a lot of investments were denied at that time to us because people didn't know if it was legal to launch a rocket privately in India.
mm,
And there
mm,
was no policy clarity when we started.
mm,
Now it's completely different. Now there is super clarity. In fact, we have a
mm,
launch pad within a within the ISRO complex. So that is very clear now. But at that time it was not.
mm,
People is, I think, from that time to today it is always hard. I think people is one of the hardest problems in this game or any game actually. In fact, people make or break any company. I think so. People is always hard, but we were very lucky because we're part of a academia ecosystem, and space as a sector is a very passion-driven sector.
uh,
So when you're solving for the early years where you're more focused on tech people, on engineers, it's very easy.
mm,
The moment you scale a little bit and now you're looking at building a business where this involves sales and finance and strategy, those kind of things, there it again becomes a little bit like that person may or may not have a real inclination for space,
mm,
right? So then it becomes a different kind of a problem. But the very early years, I think we're very blessed actually. We got an amazing group of people in the first 15, 20, and almost all of them are still with us in that from that group, and that has made a lot of difference to us.
And these guys came from where?
Mostly freshers, actually, just coming out of
Oh,
master's
wow.
degrees. Yeah.
Wow, amazing. Without much experience.
Yeah, without much without experience, I think literally. I think that actually because we augmented them with retired people from ISRO, and that's how we saw because we were very clear that anyway there is no other talent in the country, right? So we solve for attitude, we solve for people who are willing to learn, who wanted to do something in space sector, and try to pair them up with some of the best retired minds in the country. And in that way, because of even not really knowing how deep the problem is, people were coming up with a lot of innovative ideas. So that ignorance actually helped in innovation. I am seeing the same people now actually they've become a little more of an expert. And so the innovation potential is slightly questioned because they know what all can go wrong. When you don't know what all can go wrong, I think there's a lot more risk taking, a lot more innovation.
Yeah. Just curious, when you go fundraising to an investor, and obviously everybody looks at lots of dollar signs when they look at the sky. Uh, so, do they actually understand when you explain to them that this is how I'm going to make money and this is how you're going to make money from the money I make? Do they actually understand that? Because if you're going to come to pitch to me, I will have no idea how to evaluate you. I'll have no idea.
Well, it takes time definitely because they are not in the industry, right? So we try to keep the tech separate from the business. So it's very hard to build as an engineering problem. So we try to talk about that separately. And then when it comes to making money out of it, then we go to the absolute fundamentals, right? What does it cost? And how much can I sell it for? What profit can I make? How the cash flow will come? And assuming the rocket is a black box that's flying, can we make a business out of it? Right. So that's how, and it's actually fairly straightforward as a business that way. If you take the tech complexity out of it, you can talk about it like a transportation business, right? And that a lot of people understand.
Interesting, interesting. So the next question is also from an anonymous person. How are you incorporating? Okay, let me see this before that I get to this question. When will you stop? When will you stop software and declare that all are fine? I'm not sure what that question is meant. Whoever asked the question, can you ask the question?
Wish is Ramakrishnan from Bangalore.
Yes, sir.
I think you already mentioned about the testing. See, the software, you talk about unit testing, integrated testing, and at some point, no, there is always an unknown bug. But this type of, suppose if it happens to be the railway reservation, it's not much. Maybe the chart is not okay or something like that. But in this type of space and rocket application, this is very, very crucial. Because with CMC, I used to go to ISRO sometime. There's a big software team and that MCF Hassan. Okay, so I used to go with the hardware engineer. But till that rocket takes off, they all of them will be definitely praying to all gods and all that. So that's what actually. And then my second part of the question is how, for example, Tamil Nadu government or Karnataka can encourage this rocket or satellite application. How it will be useful to a government.
So what is the end to software testing? Actually, yeah, it's asymptotical, sir. We never really get there. We always find it like, okay, a few more tests will always be good. We try to come up with thousands of cases, thousands and thousands of test cases at every level. We do multiple code reviews. We do code reviews as a team. We do code reviews with advisors. We do independent code checks. We try to write the same module by two different people and then replace the module and check the same program. Like we do hundreds of these things. And still I found things where 5 days before the actual launch, we found a bug and all. So I think it is just a process of getting there and just a process of rigorous testing. There is no shortcut. You just have to think of all possible ways in which you can go wrong. And that's quite a few ways. And the only way out of it is by this brute force, doing all of those test cases and running the software in a configuration which is like it'll be in its flight. Anything you do to say that you're not mimicking flight is a problem, because that itself there may be a hidden bug there. So that's how it is. I think I've read somewhere that they say art is never complete, it's only abandoned midway. Similarly, I think code without bug is never complete. It's abandoned midway. So that's about the software testing. And it comes to the second question about government and what space technology, how it can benefit. I think space is now a tool, right? Just like we had tools to do something, anything better. Now from space you can take better pictures, track things better, help with better communication, help with bunch of other things, because it's basically sending data back from a particular vantage point. That
Okay.
could be communication data or imaging data, but we're able to cut through clouds now, cut through dense forests now, cut through even some small hills now. So you're able to penetrate and look at everything, and you're able to do that at a repeating frequency. You're able to do that at lesser cost. So it's like suddenly you have that view of that location, both from a communication and imaging standpoint. So I know of projects where people have governments have tracked illegal buildings, height of build heights, buildings that have been built beyond their allowed heights.
Right.
I
Right.
know of government projects where they've tracked the number of illegal boats on their course. So once this it's endless. As far as the data is available, you can do a lot more with it. And I
Okay.
think the engagement for these technologies will come with subsidies, right? I think all of these companies, satellites or rockets or data processing, we all need a lot of infra. So any subsidy from the government usually helps. I think Tamil Nadu has a space policy now, which we benefit from.
Okay.
Similarly, Karnataka has, I know Gujarat is coming up with one, I know Andhra is coming up with one. So I think people and state governments are realizing the need for it also.
Thank you. Thank you, Srinath.
So what specific does Tamil Nadu government do for you when you said subsidies? They subsidize your manufacturing or subsidize
A
your
bunch of things are there. So, like for example, if you have done R&D, and
uh,
generated a patent, then they give you a large part of the money that you have spent on that back, right? If you
oh wow.
and if you have invested in machines and you're doing that, you're using it mainly for R&D, then actually a part of the tax that you pay comes back. Electricity you use for running that machine, again a part of it is given back. People, there is a particular token amount, not token amount, particular amount for people who are employed in R&D. You can get this part of the salary reimbursed. A bunch of these are there.
Oh,
Space
wow.
policy, Tamil Nadu space policy is actually quite subsidy friendly, I would say. Yeah, it's
Hmm.
not like they give you upfront money, but if you spend the money, you can get a lot back.
And national level framework.
Yeah, that's also there, right? So we have this new fund that was announced, where I think 1,000 crore fund. It's small, but okay, at least it's a start. Now there's a deep tech, initiative that has also been announced. And facility usage has been made affordable. So yeah, that's also there. Think we just have to. Only challenge I find is there is no single place where all this is clearly listed. No, there is no one place where I can go and see, okay, these are the things. Finding that is its own art. But once you are really at it, and if you dig hard enough and long enough, you will find a bunch of resources where it's not like huge pockets of funding, right? You won't suddenly get 100 crores, but you
Hmm.
can get 15 crores in 6 7 places. It's like, sort of
Hmm.
like that.
And I
I guess
think
fine.
Nicole is the first to be onboarded on in space, right?
Yeah, that's right. We wrote a letter to Chairman ISRO at that time. The moment it was announced in May that we want to be part of this program in space, and we want this and that, and we want permission to launch directly. That time itself we wrote, and ISRO was kind enough to give us a meeting and talk to us about all that. And so since then we have been one of the first players to get these benefits, and yeah, we were the first player to sign with in space actually.
So through in space, you get the testing facilities, or what are the benefits you get through in space?
A lot of facilities actually, I mean, a lot of things actually, they are primarily for authorization, right? Someone has to say
Okay.
AgniKul is allowed to launch, and that's from in space. But beyond that, to get a launch done, you need to work with so many different centers or ministries and so on. So that single point window system happens through in space. Then before you get ready for launch, testing and reviews and all that, that also happens through in space.
Okay.
Super. Shruti, you have some questions? Go ahead.
Yeah. So I have two questions. The first one is, talking about this topic, it also brings me back to my CG memories. My first trip out of India was to the European Space Agency. So our project was built on, self-healing networks and circuits. So when you mentioned about so many, bugs and errors being so critical, I'm just curious about approaches being used and whether, techniques around self-healing are being adopted.
No, actually, the only technique that we use other than very rigorous and systematic testing is redundancies, right? There is very little time to react. And actually, an entire rocket is on autopilot, right? From the moment actually there is this phase in the countdown which we call as the automated launch sequence. It's usually about 2-3 minutes before the launch, or sometimes 5 minutes, whatever. It depends on the rocket. But from that moment, basically humans have let go. You stand and watch the show, right? And one thing you can do if it's on the ground is there is that abort button and you can abort the launch. But other than that, it is mostly like sitting back and watching things happen, and it could be a good day or a bad day. So and the reason it is done that way is because things are happening so fast. It's a highly dynamic system with and flying in what we call a stochastic environment, right? It's a dynamic environment. We don't know how the wind should be. I mean, we take day of the launch, wind observations. We do a lot of study, but still, it is what it is. If there could be a wind, there could be a gust that you can't predict. You have to design around that. So it's very little time to correct in flight. Particularly for these kind of this phase of the flight, it has to be autonomous. In fact, autopilot as a control systems theory developed in rockets and orbital class rockets, right? It is that jargon was first used, in my understanding, at least in rocketry. So the only way to fix this is redundancy. So usually there are multiple levels, multiple dual redundancy, whatever it is, whatever you can afford, how much of a mass and money you can afford in your vehicle, you put it into the vehicle and then write code for that. I have realized that beyond a certain point, the code to debug a problem in flight without losing precious time and switching to a redundant system is as hard as actually, just allowing one thing itself to not happen. It's incredibly, because you get like 10 to 20 milliseconds to do in-flight debugging, and that is very difficult because all your symptoms are going to look the same. Whether an engine blows up or whether a pressure sensor fails, it's same pressure sensor reading is out of bounds. That's what the flight computer is going to read. Right now, to go and see whether it's a real sensor problem, which means it's basically no big deal, I can continue my flight, or whether an engine itself blew up, which means I have to shift to a new algorithm for my autopilot. Right, like those kind of decisions to happen in 20 milliseconds, that in a meaningful way, is very hard. So the debugging, the in-flight debugging part is actually quite challenging, but redundancy is the only way out in my understanding.
Because the cost of failure is of course even much higher, right? So I'm sure redundancy is probably the answer right now. My other question is around sustainability, both from the point of materials being used. You mentioned about the additive manufacturing practices, so the material being used, because we are also talking about a lot around space debris and all that. So how are you trying to incorporate sustainability, or is it even an area of focus at this point?
It became an area of focus indirectly. We didn't start off with that right in mind, but so additive manufacturing, again, as I told you, it came in because of economics being the best way there. But additive manufacturing, I think, is literally probably the least wastage way to manufacture anything. Right. So by definition, you're throwing away lesser. You only do what you want. The rest is collected and used back again. Right. So it's a very, very eco-friendly process that way. And it doesn't usually involve any toxic systems, gases, or anything of that sort, nothing corrosive. Then when you go to the vehicles systems itself, we went with the liquid propellant system. So we can reuse it. We're not simply dumping stuff. So we're not throwing away after one use and so on. So that is there. Then liquid propellants compared to solid propellants are also less corrosive, less toxic, less, just less punitive on the environment. And even within the liquid propellants, we use the safest of the safest, which is kerosene and liquid oxygen. It's basically the same amount of problem that a jet plane would give. Right, that's sort of the same approach you've taken. So we're just burning kerosene and liquid oxygen. That's it. And the kerosene we use is aviation grade kerosene. What we in fact get our propellant from airport. Chennai airport is where we got our fuel from for the last flight. So literally that level of focus you've had in terms of, again, a lot of these were actually driven by economic parameters. But interestingly, there is a huge coincidence with sustainability also coming along. So we're not specifically solve for it, but we keep an eye out for it and try to solve for it if wherever needed.
Thank you. I honestly wish, especially logging in from Bangalore, that some of this technology, if at all, matures at some point to even give us a vertical lift off it to beat the Bangalore traffic would be amazing. So,
Agree.
Rocket in Bangalore to go from Sajapur to, well, yeah, definitely helpful. Okay, thanks, Sudhi. Rajesh, you had questions? Rajesh, you're on mute.
That's one thing we can't solve, right? So, first, Vish, thanks for bringing this together, Vish, and
Yeah.
your team is doing a fantastic job. And Srinath, kudos to you, man, for pursuing your passion. You're really a role model, right?
Thank you.
And I also feel a little proud because I also came out of Triple E. So, out of Triple E, some good things are happening. Okay. Srinath, so my question is, in the ways of working that you are all following in AgniKul, are you all following agile ways of working or is it traditional waterfall? The context for my question is, we all know Elon Musk doing great things with Tesla, etc. What is not known is not just the products he makes, but the way he runs his organization, the way work is designed within Tesla is just incredibly different, right? So, how have you approached workflows in String in AgniKul?
Yeah, great question. So it's a mix because certain teams demand it a certain way. So the first principle is once you make a decision, don't deviate, right? So that is this. I think actually Russians or someone had this saying that democratic decision making but autocratic implementation. It came from, I think it comes from the Russian space agency, if I'm not mistaken. But that's what we follow too. Allow people to talk, allow people to come together, but when you execute, just follow orders. But it is very hard. It's very hard to tell people not to think.
Yeah.
It's very hard. It's been one of the biggest challenges I've faced. And then coming to getting work done, the other thing is extreme focus on systems. So there's no such thing as, like if you can't integrate things together, then the software has to be written for a particular version of hardware. The hardware has to be written for a particular version of software. Everything is so tied into each other. So we encourage a lot of common, communication as much as possible. Literally people sit in one room, like the entire design team sits in like 20 feet by 20 feet or 30 feet by 30 feet room. That actually helps a lot because only then people talk. Otherwise, it becomes like a college, right? That is triple E department, there's EC department, there's computer department. We talk only in lunch, and that doesn't work. The next thing we do is so in certain areas where you need to be hierarchical, where you need to follow a certain set of rigor, we follow that. But otherwise, it's mostly on the agile side. Right? Keep going, make sure what are your real obstacles and see if you can solve it and then communicate with others because no decision can be really made independently. But that doesn't mean you should always wait for 100% consensus. So driving the balance is the hard part actually.
Thanks, Srinath. My follow-up question, the reason I asked that is, just as your vision is to democratize space travel, I work in the business of my vision is to democratize workplaces, correct? So if from that perspective, nice to know. I was so happy when you said you had an incredible set of first few 15 people, and and like and I was so thrilled when you said they're all freshers, right? It's amazing. But as an organization grows, culture starts diluting, correct?
Yeah.
Do you face that issue? If yes, what thoughts? How are you planning to address those?
Yeah, we face that, right? It's because the culture comes from the founder level. In my time, that I can spend with people obviously reduces the more people are added, and my responsibilities itself have changed, right? Like from building rockets, it become about building a rocket company. So my role.
Awesome. Very well said. Very well said.
That actually was said by one of our mentors, but yeah, I think it's very true. Now the expectation is, in fact, now if I build anything about rockets, investors and board members are like, why are you not having us do this for you? Very true statement. So no, I think that is definitely a hard thing. And the only way we can reinforce it is to still find multiple ways in which we can spend time with people and allow the first set of people who have worked with us for a really long time to keep talking about that. So even though what I realize is even though they understand the culture, they're not able to propagate it because it is not gotten into them that deeply.
Exactly.
So then the question is about, okay, how do you get them to do that? And that's a process. It's not a, I don't have a single solution to it, but multiple ways. I try to some of these very preliminary meetings, for example, when you go through a design review process, even though today there are multiple people in the company who can take it to almost the execution itself without me. I sometimes randomly jump into some of these early meetings, and then people are very confused about why I'm sitting there. But then that's one way for me to talk to the people directly, right? So that's one way I keep doing that, and I tell my direct reports also always to keep that culture part in mind. What are they really solving for?
Yeah.
But it's work in progress. I have not been able to be as successful as I should have been in it, I think. But we are getting there.
Awesome. Very nice. Thanks, Srinath. All the best.
Thank you, Srinath. I think we have come to the end of the questions. One last question I have for you: that when are you going to start calling you Elon Musk of India, or Elon Musk as the Srinath of the US?
Yeah, I don't know. I don't. There was a time once when Elon was only known for space and Tesla. Now he's getting known for a lot of things.
So you don't want to be known with his name, anything to do with his name.
Yeah. I don't know. Maybe we can. I think it's better for AgniKul to be the SpaceX of India. That will be a better thing. Whether I should be the Elon of India, that's a whole different problem statement.
But you think that SpaceX's work is really that dramatically groundbreaking?
Very much. They're the first people to actually commoditize space. Until then, it was like three big industries with four big governments coming together, and no one really knew how to price a space product. So they opened that up. Very, very, very strong. I think today we are all talking about space because of space.
So will they be looking to acquire you at some point? Possibly.
I don't want to be acquired by them. I would like to go IPO myself.
But is it a business that they will be interested in?
I don't think so. They don't. They've not shown any interest for it because there are a lot of these smaller companies in the US itself that they could have acquired, right? Rocket Lab, for example. But they are very keen on building the biggest of the biggest of the biggest rockets. So small rockets really don't seem to be their cup of tea. So
I see. Super. Anyway, I want to also thank you for recruiting all the CG students. I know you have a lot of CG students in your company. The last batch of 30 students who unfortunately had to work through a offer withdrawal, you're able to help them. So I want to definitely thank you for helping those students and taking them on board. There are a few more I want to send it to you to evaluate as well.
Sure.
But thanks for joining the call today. It's very interesting. Not very often we hear about rocket launching and how rockets work, except during Diwali time. Otherwise, we don't know how rockets are working. But I mean, it's interesting to see that the rocket company economics is different from building the rocket. Obviously, it's a totally different skill set required for that. What kind of people are you looking for now in general? If to expand your company in terms of resources, are you looking for people who are more in the tech side or more in the business side, or
everywhere? I think we are expanding. So all areas of engineering and all areas of non-engineering. I think there is always a need. Various levels of seniority, but they're even starting from freshers all the way to some reasonably senior positions are there. So and we don't. One thing I've learned also is to not solve too much for teams or departments. Today, at least if it's a position that comes to me for an interview, that means it's somewhat mid to very senior. If it works at a culture level, I don't even find something. You put some title and come and we'll figure out what to do if you can work with us. Right? So solve for the person, then solve for the title and the role and the actual job. So that's how I have changed in my one philosophy itself.
Excellent. Thank you again for joining, Srinath. I know it's been a long session, a little longer than what we expected, but it was very interesting. Thank you, Shweta and Satyapriya, for running the session for us. This session is recorded, Srinath. Would you like to see the recording before we publish in YouTube? We can give that choice to you.
No, it's fine. I think we didn't touch any controversial topics. It should be
okay. I just give that option to all my speakers because some people want to see what they say.
Yeah, I think I don't want to be it'll become a bottleneck. I'm pretty sure I won't get the time to see it on time, and then honestly, and so and you told me it'll be on YouTube, so I avoided stuff that I would avoid on you.
I shouldn't have told you. I should not have told you. And those who are watching, if they want to reach out to you, I guess I will given them the LinkedIn link for that. I guess that's sufficient, right? People want to reach technical through LinkedIn, right? You see,
Yeah,
you do see LinkedIn, I hope, right?
yeah, I use best way is to write to that Srinath at agnikul.in. That's my ID. Usually, I check emails. I check every day. So
Okay, super, very good. Thank you so much, Srinath. Thank you, Satya, and
thank you, sir. Thank you so much for having me. Thank you.
Thank you.
Fantastic.
Thank
Thank
you,
you so much.
Srinath. Thank you.
thank you, guys.
Bye bye.
Good night, guys.
Thank you. All the best.